So again, back here in basically the same place, and so last time we left off right here in this book, and we were talking about linear equations. Now, not just any linear equations, graphing and slope. So you left off right here. So then we'll continue here on slope-intercept form. Now, if you didn't watch last video, well, you probably should watch it if you don't know about all this stuff, since that's basically the most basic stuff that we'll need for this week's lesson. So for slope-intercept form, and we see that as noted earlier, aka as noted yesterday, the most common form of a linear equation is called the slope-intercept form. In the equation, y equals mx plus b, which is the slope-intercept form. M represents the slope of the graph of the line, and b represents the y-intercept. So slope-intercept is actually pretty easy to relate to real-world relationships. For example, b represents a starting value, like the y-coordinates. B represents the starting value, and m represents the rate of change. And so slope, well, it's not going to be like slope. It's not going to be jagged or something. It's not going to go like up and down or all like that. It's the constant rate of going up or down. So B represents the starting value, and M represents a rate of change. For example, the cost of C of a phone call, which is the Y, the cost of the phone call is going to cost $0.49 to connect, or just to call them, and then $0.09 per minute, and that could be represented by the equation C equals 0.09 times M plus 0.49. So here, basically, our y-intercept is 0.49, and our x-coordinate is 0.09. So that's basically slope-intercept. Now can use that in the examples here. Write an equation in slope-intercept form for each line graph on the coordinate plane below. So I already drew this out for most of you. Let's look at line 1 first. Well, again, so we pick, 2 points on the line, just like before. So you pick 2 points on the line, we find rise and run, and you pick rise divided by run, just like how we told you how to do these lines yesterday. So now, it's in real coordinates. So I'm going to ask you, when you're picking lines, what points should you look at first, or what points will be easiest for you? It's going to be the two intercepts, your y and x intercepts, since here, one coordinate always is 0. Now that has a little exception. That's only usually if the y and x intercepts are a whole number. Since you don't want 3.14, I'm not going to say all the pi, but let's say I don't want 3.14 and 0 and 6.5 and 0 6.5. So I don't want any decimals and all that. So look at for line 1, I look at the intercepts first. Y-intercept and x-intercept. Well, the y-intercept, if you look closely, I put a dot right there. The y-intercept, the line 1 intercepts that y-coordinate at the point 0, 3. So that's a whole number, right? So I'm going to use, hold on one sec. Here, this. I think I wouldn't need everything. Here's the page. So I'm going to use the point 0, 3 as one of our, let's say, like sample points, 0, 3. And then we look at the x-intercept. That kind of intercepts a little over 4. Now a little over 4 is not 5, it's not 4, so that means it's a decimal, and we don't want decimal. So we keep looking for other integer points, and we just go a little more on this line. So at this point, where line 1 intercepts line 3, right there at that point, is 6, negative 1. Negative 1. So let's say these two, 0, 3, and 6, negative 1, these are our sample points. And then, we don't need this anymore. And to find the slope, well, we take any two y-coordinates subtracted, which is the rise. So slope is rise over run, or any two y-coordinates subtracted, and in that same order, the two x-coordinates subtracted. So algebra run here. Slope. Well, let's say take 3 of the first y-coordinate minus the second y-coordinate. 3 minus -1. 3 minus -1 is 4. And then in that same order, 0 minus 6. And 6 minus 0 might be, I meant with 10 things since, well, it's a positive number, but we can't do that. So 0 minus 6, which is, as -6. Now, other negative, we can move that up here. And 4/6 is 2/3. So the slope of this line is 2/3. Now again, look at the problem. We want to write an equation in slope-intercept form. So not the slope, but we want slope-intercept form. Well, to do that, again, slope-intercept form is y equals mx plus b. So y equals mx plus b. Well, y coordinate is still the y coordinate. M here is the slope. Right here. That m is the slope, which we found is -2/3 times x. Now what b is? But b is, well, b again we think is the y-intercept from back here somewhere, and b of the y-intercept. Also, well, that's where line 1, which is the line I'm working at, intercepts the y coordinates. So that's right there at the point 3. So the first answer is y equals -2/3 times x plus 3. Now, and now we could check this -2/3 again by thinking, well, -2/3 means it's sloping down, and sure enough, this is sloping down, and the answer also says the exact same thing. So we're pretty sure